Hello, everybody. Welcome back for a new midnight session. Let's see what we have new for the ecosystem. Let's start talking about Keystone. Keystone, it's one of the partners that are going to start developing along using Midnight technology. So let's take a look. What are the capabilities of Keystone and what this company actually does? So let's open here the web page of Midnight, saying that Keystone is one of the partners. It's a secure cold wallet for effortless transactions. So let's take a look at their website. See, we can hear one of the devices. This is the Keystone 3 Pro. I want to thank Keystone as well for giving away 100 hardware wallets for all the developers that attended the Cardano Builder Fest. So thank you, Keystone. I have tested your hardware wallet. It is really awesome, and I recommend everybody to have one of these hardware wallets for security. Let's see some of their features. So this is one of the wallets that they have 3 secure element chips. So you can have up to 3 seed phrases in your wallet. They use this air gap cold wallet. So the transfer of documents, transactions are as an air gap. So that adds a lot of security in the process. And they have this PCI level anti-tamper. So if anybody wants to tamper your hardware wallet physically, they provide safety mechanisms for that. Let's see what else they have. It's all open source. The software and the hardware part implementation, it's open source. And they have this anti-blind signing. So normally when you sign a transaction, you depend on whatever the hot wallet tells you are signing. But also in the hardware wallet, they're going to display the actual structure of your transaction. So you don't have to believe on any UI. You are actually going to see what you are actually signing. So that's a big plus. And they have this big screen, so you're going to actually be able to see what's going on with your transaction when you're signing smart contracts. This is all the partners. And they have a camera. So it's pretty much like a cell phone. And the security implementations they've done, it just impresses me. So good job, Keystone. Okay, let's see what we have in the blog section. Midnight, they just posted the state of the network for May. So let's say what they have to say. They announced the Midnight Foundation and the Shielded Technologies companies. So this is how Midnight ecosystem is now going to be structured. Let's see what these companies actually do. The Midnight Foundation is a core constituent of the ecosystem. It's an organization committed to the growth and adoption of Midnight. So this is like a foundation for Midnight. And then we have Shielded Technologies. It's the core engineering team driving the development of the technology behind. So this is really good news. We have 2 big companies, businesses, and 1 foundation supporting the Midnight ecosystem. And in the future, more companies are going to join the game and the ecosystem themselves as well. We are all going to give support to the Midnight ecosystem. Regarding the learning resources, we are actually going through all this material. We have these dev diaries and the academy that they just launched. And regarding to partners, they just keep adding new partners into the ecosystem. So we are seeing how the Midnight team is actually pushing really hard for enterprise adoption. And regarding the releases, we talk about this in the last session, but it's the new updates are regarding the libraries for this testnet 02 upgrade, a new indexer they just released based on Rust. and they are starting to open source some repos and examples. So after all these translates to we want to have more tooling for developers and users to actually do something on the Midnight ecosystem. Okay, so the education part, right? There is 8 modules. We are going through each of these modules. In this session, we're going to talk about decentralization, consensus mechanism, and we're going to talk about blocks, nodes, and immutability, right? These are concepts that we need to understand so we can actually then see how different parts of the Midnight infrastructure connects to each other. So I have made a summary. So these concepts are clear. They're talking about decentralization. So what is decentralization? This is a really complex term, actually, right? It's not simple, but I'm going to give you some context. We talk about no central authority. We talk about distributed ledger. We talk about a trustless system, and also a fault tolerance, right? If we want to go more into detail, the Cardano ecosystem, they actually partner with the Edinburgh University, and they're starting to create this index, which is called EDI, for different blockchains. So we can actually compare how decentralization, how decentralization index compares to different blockchains, right? So I have here the web page, which is it's all open source. They explain their mechanics and actually some metrics, right? So we have they compare decentralization based on consensus, based on tokenomics, based on software, based on network, and based on geography, right? So you can see, right, decentralization depends on so many metrics. Let's take a look at metrics, for example, at consensus level. They are comparing Bitcoin, Bitcoin Cash, Cardano, Dogecoin, Ethereum, Litecoin, Tezos, Zcash. We can see that Cardano, it's the key, right? And something nice about Midnight, that we are gonna use Cardano consensus for actually securing our blockchain. So yeah, we're in a good shape. Okay, what other topics? They talk about the consensus mechanism. There's a lot of different consensus mechanisms, right? But we're gonna talk about the principal 3 of them, which is proof of work, proof of stake, and BFT, right? Bitcoin, it's proof of work. Pretty much miners solve puzzles. So it requires a lot of computation. That's why it's really costly, right? That then Cardano started, they developed this Ouroboros consensus, which pretty much compares to the same security as Bitcoin has, but with less cost, right? So it's more cost efficient. Validators are selected based on stake coins, and it's energy efficient, faster finality, and aligns validator incentives. And then we have BFT. This handles faulty malicious nodes and uses voting rounds for agreement. This kind of consensus has a faster finality than the other 2, but it's more centralized, right? So you need to know in advance what are your nodes. Or actually, BFT, it has also different families behind that. But yeah, we can, for example, Midnight, they're talking about using something about BFT on the Midnight nodes, but actually we're going to be securing at the consensus level by Ouroboros. So you see how these different consensus can mix each other for specific parts of the tech stack. And then we have blocks, nodes, and immutability, right? Data is grouped in blocks, each linking to the previous hash. That's why it's almost impossible, depending on the size of the blockchain, to actually hack a blockchain. Because if you want to change something, you're gonna have to change. You're gonna have to convince to all other nodes to actually make that change and change all the past. So you're gonna have to change history, and that's really costly. We have tamper resistance. We have ledger copies on many nodes. So we have replication and immutability. So these three concepts are the reason we have blockchain, and they provide a really nice features when we are actually developing applications. Okay, so now let's talk about the DevRel hangs, right? We have these hangs every Wednesday. In these last hangs, I was invited, right, to talk about what we are doing with Mesh, what we are doing with Edda Labs, what this midnight session is about. And one of the hot topics I mentioned during the session, it was the wallet widget. So we are updating this wallet widget, but at the end, developers are going to be able to just plug in this wallet into your application. You don't have to worry anything about the workflows or UI implementation. It just works. You just connect to your lace and see here, you're going to be able to see your address. And then you're going to be able to copy and you're going to be able to disconnect. So that's huge. I'm sure that everybody's going to like it. Okay. So now the hackathons, right? We have the ongoing hackathon. For those that haven't yet signed, I'm going to show you how, right? You go to developers hackathons. You're going to get to this site. Here, you're gonna be able to register, right? Here they explain all the scope of the hackathons. As I mentioned before, let's take a look here again faster. We have different categories. We have the developer experience, libraries category, CLI tools category, dashboards, integrations category, and NFT design. And we have some deadlines here. The hackathons open on May 19th. The registration, it's until June 13, right? So it's 1 week, so you have to hurry up. The submission, it's on June 16th, and the pitches are going to be on June 20th. I'm going to be one of the juries, so anybody who wants to join the hackathon are welcome. Mesh are giving support. We have a Discord that you can join. You can ask questions. And just ask any questions, and we are really happy to help you guys out. Perfect. So now let's go to the technical part. In the last sessions, we were discussing contracts, compilation, configurations, YAML files, but we haven't seen any APIs on how to use the compilation of our contracts to actually talk with the different instances. So now, under the control CLI folder, we have the API file. This is where we're gonna list all the different functions that are gonna do something for us. Okay, so let's start explaining what each function does and how we actually implement it. We're gonna first start with the get counter ledger state. So this is a function, it's asynchronous, and we're gonna have two arguments. One is the providers and the other one is contract address. What is providers? Providers, and that's something that we mentioned during the last session, we have this graph, right? So this is just a summary from the last session. We have 6 providers: the indexer, the nodes, the proof server, the wallet, the oracle, and the cryptographic materials. So this is the providers. This is what our code needs to actually create those circuits and talk with the node. So we pass here the providers. They have this type, counter providers, where we declare that under the common types. So if you haven't seen what is these common types, I invite you guys to go to the previous session where I explain how to configure these types, YAMLs, and all this configuration stuff. So there we declare the type of the providers, and then the contract address. it's a contract address, right? This type, we are getting it from the Midnight libraries under the compact runtime. So perfect. This function, it's asynchronous. It passes two arguments, providers and contract address. And it's going to return a promise of a big int or a null. Now, we'll run this function. Assert is contract address. Where is this function coming from? It's coming from a library of Midnight, midnight.js.utils, right? So I know what it does, but in the case that is the first time you're seeing something new, we have the docs, right, of Midnight. So we can go to the docs. And here we're going to find all that documentation that we are looking for. Something nice about the docs is that the Midnight team have implemented this AI. It's based on Kappa AI, right? So it uses a basic LLMs, but it's trained and it's anchored based on the docs of Midnight. So it doesn't have that kind of hallucinations. So people are starting to test it, and as more examples, more code, more everything, this Kappa AI is gonna get more proficient. So if you click here, you can ask any questions, right? The other way to get into this Kappa AI, it's going on Discord. On Midnight, you're gonna have this Ask AI. So this is another way to talk with Kappa, right? You just create your post and Kappa is gonna answer you and explain everything, right? So really recommend it. Go ahead. We can see here that people has started talking with Kappa. See, we see here people. Yeah, John Santi. I know you love Kappa. Yeah, it's perfect to use the resources that we have available. And what it's nice to talk in Kappa here is that the learnings that people go through, others can see and learn at the same time. So really nice. Okay, so we were trying to look for this function, right? Assert is contract address. So let's copy it. Let's test Kappa. So we have copied the function. We have two options. One, go through the documentation and find that function. We saw that this assert is contract address is coming from Midnight.js utils, right? So if we go to the docs, we have the Midnight APIs documentation, and we can see that it's under the Midnight.js API and utils. Here we can find the functions, and we are looking for assert is contract address, right? If we click here, we're gonna be able to find all the implementation of that function and what it actually does. It says here, asserts that a string represents a hex encoded contract address, right? Also, you can just put your cursors on top of that function. Since we're using TypeScript and all that declaration are embedded within the functions of the libraries. So you don't need to go through the documentation. It's needed if you want to go really deep into how that is implemented. But if you want just to take a look at the arguments and some information about that function, it's just tapping your mouse on top of this function, and these details is going to appear. So we can see here that we have the same information. Assert that a string represents a hex encoded contract address, right? Perfect. Let's see if Kappa knows how to respond that, right? Let's ask Kappa a simple question, right? What is let's be more clear. What this function does, for example. Let's see. So the assert contract function is a utility function in the Midnight library that validates whether a string represents a properly formatted contract address. And here it explains the arguments, and then it gives us the reference, the documentation where Kappa took that information from. So it's nice. it's anchored to some actual information. So if we click here on the link, we can see that it's going to open that documentation that we were looking for. So yeah, Papa, it's a must. You have to use it. So perfect. We can see here that we are asserting if this contract address that we are passing to that function, it's actually a hex encoded contract address. It's just for security means. Okay, if that validation passes, it's gonna return a string. And if it doesn't passes, it doesn't return. And then we are logging, checking contract ledger state. Okay, now we want the state of that contract address. So what we are gonna do now, we are gonna use our providers, and let's see what these providers actually give us. We can see that we have a Midnight provider, private provider, proof provider, public data provider, wallet provider, and CK config provider. We can see that it's 6 of them, right? We have this other one, Logger, because in the providers, you can actually add other custom providers. But the ones that are provided by the Midnight team are these 6, which are these 6 providers that I just showed you, these 3. So perfect. With the providers, we're going to be able to talk with those instances. Perfect. In this case, we're just talking with the public data provider, which is the indexer. So with these providers, we're going to be able to get some information from the indexer. Okay. And when we select one of the providers, we have also some methods. If we see here, we have all these methods. We have contract state observable, query contract state, query deploy contract states. So a lot of them, right? The one that we're going to use, it's query contract state. So we just want for the indexer to get us some information. That's it. We don't want any observable, nothing at all. We just want a information, a request and a response. And then we pass the contract address. So we're telling the indexer, this is the contract that I want to take a look at, and I want some information from there. So I'm passing the contract address, and then, right, this is a sync. Once we get that information, then what I'm gonna do with the contract state. If it's different than null, I'm gonna get the ledger function. Where this function is coming from? It's coming from the object counter. So this counter, it's from the first part that we did. So again, you can see my last sessions where we explain how to compile a contract. And once we compile a contract, we're gonna get the class of a contract where it gives us some information how our circuits are implemented, and a function called ledger that actually deserialize the state of the contract. So this information here, it's serialized. Using this function ledger, we actually deserialize that information. So what we have, it's the contract state. We can see that we have data and we have maintenance authority. Maintenance authority, it's a function that we're going to see in the future, but it's really nice that allows us to actually update our contracts if something changes in the proving system. So now we just want to deserialize the state of the data. And then we're gonna be able to see the different ledger variables that we're using. In this case, it's round. If we go back to our contract, we can see that the only ledger variable that we are using is of type round. So that's why we see just round. If we had declared other variables, ledger variables, we would be able to see them all here, right? But we only have round, so we're selecting round. And if there is no contract state, I just return null. And then I'm just logging the state, and then I'm returning the state. So this function at the end, what it does, I'm passing the providers, so I'm gonna be able to talk with the indexer. I'm passing the address of the contract that I want to get the state from, and just talking with the indexer saying, hey, give me back, send me back all the information from that contract. And then using that function to deserialize that information and get the structure of the data that I declare on my contract and just returning that state. So now we're going to be able to get the state of our contracts in our code. Another important function or constant we need to have is declare the instance of our contract. So this is going to have type counter contract. Also, this was declared on the common file we saw on the last session. And how do we declare that instance? Again, in the compilation of our contract in the first part, we got the class of the contract. From that class, we get this function ledger, and also we get this class contract. And to initialize that contract, to get the contract instance, we have to pass our witness. Again, this witness was declared on the first part under the witness file. So see, we have a witness. In this case, it's an empty object because we don't need any private information. But still, to initialize the contract class, we have to pass the witness. So now we have our contract instance. Perfect. So we've seen how to get information from the indexer and how to initialize an instance of our contract class. In the next session, we're going to keep looking at these other functions that we need to actually implement a code and do a DApp. But we're going to stop here in this session. So now I'm going to open for questions and answers. I'm going to open the mix. If anybody has any questions, I'm opening now. Okay, the mics are open. If anybody has any question regarding these topics or any other topics, just feel free to ask your question. In case anybody has any questions, I'm going to answer some questions that I had here on the yep.
Yes, thank you. I've been following this session since start. So I had few questions regarding some things. Multiple times it was mentioned that counter is the only active repository right now. So if let's say I am working on new examples, and can I push it to some Midnight library, or is that not really something it's happening?
No, yeah, actually it's the open source we have the Midnight repository and actually the Mesh repository, right? So if we take a look here at the Midnight examples, let's see their repo here. So here let's take a look first at Mesh. So here in Mesh Midnight, we are working on some examples, right? If you have an example that you want to share, you have different options. One, you can just create a pull request for under these examples, and we can include your examples here. So anybody that wants to take a reference of how to implement some contracts based on what you've done, they can take a look here, right? And why here and not on your own repository? It's just to organize repositories and people be able to find that documentation. Also, on the Midnight side, they are working on some open repos, right? They haven't mentioned yet if we're going to be able to do PRs based on examples that we've done and they have included. But now they are creating this other repo, which is kind of a let's call it like kind of a hub of every kind of information. So you have these they call it, let's see if I have it here, Midnight Awesome dApps. So this is under the Midnight Network organization. So in the Midnight Network dApps, they have listed different dApp examples, learning resources, community projects, community video tutorials, hackathon projects. So here you are also welcome to submit any PR with the work that you are doing and examples, right? And also you can take a look at the projects that have been built by others, so you can have a reference on that as well.
Yeah, that's good. And one more thing, like if there are like bugs that I think I find, like I should report it to like some channel. Is there a channel?
Okay, that's a really nice one. Okay, you have three options, right? The first option, and kind of just not to give too much overload to the Midnight engineers in case somebody else had your problem and they know how to solve it. You can go under Midnight Dev Corner, and then here you can ask your question, and if somebody know how to answer that, they're gonna respond. The other one, you can go to Mesh, and you can actually ask your question here. But we're focusing more in this Discord regarding topics that we are looking at Mesh with the tooling built in Mesh. But it's something related specifically to Midnight. I recommend to go to Midnight itself, so we don't create any bridges, and just ask your question here. In case nobody is able to answer that question and you actually want to talk with the engineers themselves, here at the bottom, they have support channels where you can create feedback, ask for help, partnership proposals, or community suggestions, right? So it will be here and ask for help. People are creating bugs and reporting tickets under these ask for help. So that will be kind of the three options.
Okay, yeah, thank you. One last question. It was regarding the example that you said, like keys and Zakir and these files were there, right? So, what are these keys exactly? Like, why is it required? What kind of keys it is generating?
Okay, so this key, I think I'm gonna explain it that with a like here. So what happens is that here in Midnight we have these two states, right? The private and the public, right? And we have the circuit. The code that we are writing on under the circuit section, it's not actually stored on the ledger. On the ledger we just stored the ledger information, and then we have some kind of an index that your circuit is gonna talk to. But what it's sent here is just a transcript and your CK, right? This CK, it's created using a prover key and a verifier key. This verifier key lives here, and the prover is actually used to create the CK. So when you send your CK to this index, this point of communication, where this verifier key lives, this key is actually used to make sure this proof satisfies all the assertions that you want to comply, right? So it's pretty much cryptographic material and how the proving system works. You need a prover key to create a proof and the verifier key to actually verify that the proof is valid.
Thank you, Eric. Thanks a lot.
Sure, Edita. Somebody else has
hello.
any question? Yep.
Yeah. So hi, Eric. So actually, I was making a D application following the counter example, and there the first loop. So basically, you have to connect your wallet or build a wallet, right?
Mm-hmm.
So I've seen like when you connect your wallet using a seed. So that I've generated one seed before, and I'm connecting that wallet. So that takes that is irregular. Like sometimes it takes just 1 second to actually sync Other times, like it just keeps on rolling and rolling, and it just doesn't even sync at all. So I have to restart the application. Why is that happening?
Okay, so the syncing, it's because we're gonna see here that we have a function called let's see if we can find it. Wait, here, wait for funds, right? If your wallet doesn't receive funds, they're just gonna keep on waiting. I want funds. I want funds. So in this counter example, we are able to deploy our contracts in two ways. One as a standalone implementation, and the other one to actually talk with the testnet, right? In the standalone implementation, we actually use a seed that ends with 1. 0, 0, 0, a lot of zeros, and ends with 1. When you initialize that wallet, you're gonna have funds by default. I mean, it's just there because it's a standalone. You just have some instances hosted by you, and that wallet, you're gonna have funds. If you use that, you use a tested mode, you're actually gonna have to provide seed, right? You can create by 0, and you're gonna have to fund it. If when you start your application, you put your seed, it's just gonna keep on waiting for that wallet to be funded, right? Once you've sent that funds, this function is gonna pass. Otherwise, it's just keep on looping here. Just keep on waiting for funds. Once the funds arrive, okay, it progresses.
Yeah, but actually, so I've built the wallet before. I've sent some funds from my actual Midnight list wallet.
Mm-hmm.
So when I start the application, sometimes it just syncs well, and then funds, it just shows the funds received, then proceeds to the next step. And sometimes on the same wallet. So I provide the same seed every time. Same wallet, it doesn't even sync, and it just keeps on rolling, like waiting for fund. So this irregularity happens.
Yeah. And what happened? It's these instances are being hosted by Midnight, and they are just keep on testing, improving things, right? So you're gonna see a lot of how to call it? You're gonna see a lot of kind of like changes and restarts on those instances. So what I recommend you, Paul, is actually when you're testing and you just want to have a more like a better developer experience, just focus on a standalone mode. It's actually going to work everything. You're going to be able to test your circuits if the sizes of your circuits are okay with the blockchain itself. Your wallet is going to sync really well. You don't have to worry about anything about external APIs or instances being hosted by somebody else. Once everything passes and you're okay with everything and you want somebody else to actually test your contract, go ahead and start using the tested instances and infrastructure. And sometimes they fail. I've been there. I mean, like I don't experience them often because I don't use the third-party APIs that often, because I just like 99% of the time I just use the standalone mode, and 1% of the time it's kind of the testnet O2 instances.
So as I'm working on the testnet remote, so basically we are using some servers that are hosted elsewhere, right? The 5 providers are hosted elsewhere, and the good servers running locally.
Yeah.
So those servers are not hosted by Midnight itself.
Mm-hmm. They are hosted by Midnight, by even them, they are like upgrading. They are sometimes upgrading infrastructure, they're testing things. Sometimes, since it's testnet, they have a lot of freedom to actually keep experimenting on their infrastructure. So you're gonna see sometimes it doesn't last that much time, but maybe specifically that time you're testing your stuff. These 2 hours they are doing some debugging, and you're gonna experience those stuff. Yeah.
Okay, so yeah. But one more question I had is like, so when you build a wallet from seed, you pass a certain format, some hex format. But in Midnight wallet, you create the wallet from 24 seed pairs, right? So how do you, if I want to use that Midnight wallet, how would I connect?
Didn't get the question. It's You mean the browser wallet or the?
Yes, the browser wallet. So when you connect or create a wallet from the browser, Midnight list,
Yeah.
so you use the 24 phrase keyword, right?
Mm-hmm.
Suppose I want to use that particular seed in my list, that the app example. So that phrase is
Ah,
completely
okay.
different.
Okay. Yeah, that's actually a yeah, that's actually a good question. Yeah, I yeah, I've never. Yeah, you're saying how do you use those 24
Yeah.
phrases to
Yep.
actually create your seed
Mhm.
phrase, right? Yeah,
Mhm.
yeah. I've never done that in Midnight, but what I can tell you from Cardano, right? For
Mhm.
these kind of things in Mesh in Cardano, we have this function that we can create the private keys. It's not a seed phrase, which is kind of the in the HD architecture, right? We have this
Mhm.
root private information, and then we can create
Yep.
different private and public keys, right? So we just
Yeah.
create
Yeah.
one of these private and public. Yeah, but that's a good question, and actually not sure how to if it's available actually within the Lace implementation. Lace is working a lot on improving the dApp connector API, so we want to have more functionalities like signing transactions and maybe being able to get that seed phrase from the Lace wallet API. Not
Mhm.
sure
Yeah.
if they're gonna implement it because actually it adds some security concerns in the process. But yeah, it's something that Lace team and the kind of the API framework they're gonna have to discuss if we're gonna be able to do that in the future.
Yeah, that's the thing. Like, I have some experience working in Cardano applications, and using Mesh, you can actually use a seed phrase, right?
Yeah.
Yeah, to connect to your wallet. But here, that was not the case. So first, when I was running the counter example, I thought that passing those 24 seed phrase would work, but it didn't. Then I created my own wallet, that is the using the build thing, and then
Mhm.
I saw that the seed phrase is different than the seed
Yeah.
phrase that is in Night Wallet.
Yeah, what happened, Paul, is that in Midnight the addresses work differently than in Cardano, right? In Cardano we have these let's call it the coin public key that we have in
Yep.
Midnight, and then the stake address. In Midnight we have the coin public key and we have an encryption key, right? And the
Mhm.
encryption key, it's something that uh, anybody should see. It doesn't give you permission to spend the coins, but actually to disencrypt the information. So at the end on the ledger, right, on CSwap, you just have commitments. And what you actually do for seeing what you have on the ledger is going through all that information of that commitments and just disencrypt whatever you are able to disencrypt based on your encryption key. So yeah, it's kind of a different model how Midnight works related to Cardano. But your question it's valid, and not sure if it's a feature that could be added in the future. It's kind of a there's some risk assumptions that we should consider in the process.
Mhm.
Yeah,
One
but
difference
yeah.
I saw One difference I saw, like in the Cardano and the Midnight ecosystem, is smart contract address. We can generate multiple smart contract address whenever we deploy instances. But in
Mm-hmm.
Cardano, if we use one smart contract and we generate multiple address, it cannot be possible. With the same CB or hex, it generates a script address, same script address is generated every time, right? So
Yeah,
here we can.
yeah.
It's, hmm,
Yeah. Midnight, it's yeah, the smart contract stuff works uh, a lot different than in Cardano, right? In the Midnight, it's kind of in the Ethereum world, right? That you have this random, so you base on your contract state, and then you have this random, and then you just create your address. So it doesn't matter if you're using the same contract, somebody implements and deploys the same blueprint that you have, it's gonna create a different address, right? As in Cardano, if yeah, of course, if you don't depend on any private or public address that you own, if you implement the same blueprint, you're gonna have the same address, right?
Yeah. Thanks for the answers, Eric.
Thank you, Paul. Thank you, Arita, for the questions. Appreciate that. So everybody can learn in the process. And well, I see you in the next session that we're gonna keep looking at the APIs and keep learning, and the end results we're gonna be able to develop smart contracts for industries and know how to implement them in the Web2 world as well. So yeah, it's gonna be a long path but we're together in this ship. See you guys. See you next session. Bye bye.